Welcome. Today we're talking about exponent properties. As we go through these notes here, it's going to be helpful to also have our little reference sheet here for the exponent properties. So this is definitely not an intro lesson to exponent properties. This assumes that you've seen most of this stuff before. All right, so first of all, this first section here, this is all about what is called the product rule. And that means what happens, it's the rule of what happens to the exponents when you multiply expressions together. So here you can see the first two are done for you and they're sort of expanded out. X to the third is right here, x to the fifth right here, and basically end up with a total of 8 x's being multiplied. The shortcut, of course, is you just add the two exponents. All right, so the 3 plus 5 get added, and you get that. Over here, if you have coefficients, well, you just multiply those together, and then you add the exponents of the variable. So number 3, you would just end up with m to the 6th. Just add that 4 and 2. Number 5, you would multiply these regular, non-exponent numbers, the coefficients here. 2 times 3 is 6, times 6 would be 36. And then the exponents add up. That's all the same variable, too. You're going to make sure the variables are the same letter. Yes, they're all x, so you can add their exponents together. So 4 plus 4 plus 2, that's going to give us 10. All right, you guys go ahead and do numbers 4 and 6. All right, so here's what I got on this first one. You can think of it as the 4 just kind of comes along, or there's a 4 times a 1. Either way, you end up with 4 in front, and then add the exponents, you get 6. Down here, 3 times, you can pretend there's a 1 there, 3, and then you add the exponents of like variables. This was a little unlike the rest in this section, but yeah, so you add the exponents for the x's, and you get 7, same for the y's, same for the z's, so you should end up with this. All right, this next section is all about what's called the quotient rule. In other words, what happens when you divide expressions involving exponents? Quotient is the result of division. So you can also think about what's going on by expanding things out. These first few are done for us. X to the fifth, well, that's like 5x is being multiplied, x to the third, 3x is being multiplied. And basically what happens is 3 of them cancel, and then you're left with 2 x's on top. You could write that as x squared over 1, but you don't need the over 1, right? It's better not to write that to simplify it. All right, so we get x squared. Number 8, what if we have more x's in the denominator? Well, same deal. Expand it out. You can cancel 2 sets of x's here. You're left with 1, 2, 3, 4, 5 in the denominator. Now, this wouldn't just become x to the 5th, all right? You're left with something in the numerator, and really what these x's canceled out to is the number 1, right? Something divided by itself is 1, so that's where that 1 comes from, all right? Number 9, here, what if we have coefficients here? Well, they just kind of tag along. If they were reducible, we would also reduce them, but 2 over 7 you can't reduce. And then just like before, this 2x, I probably should have put a dot in between there, but it really doesn't matter. The 2, while it's next to the x, it's not really a part of it. You do cancel this, x individually with an x down here. That's okay to do. And so you're left with 2 on top, and then you have 1, 2, 3, 4, 5 x's in the denominator, and then the 2 and 7 come along. All right, let me do number 11 here. You could expand it out if you want. Oh, the shortcut here. What's the shortcut? Rather than expanding out. Well, notice this exponent is the result of 5 minus 3. Okay, so you can just subtract the exponents. This exponent here is the result of 7 minus 2. Notice if you want to end up with a positive exponent, you always go larger minus smaller. And wherever your larger amount was, that's where your resulting your resulting variable will be. So yeah, like 7 minus 2, this is the larger one, so you have more x's in the denominator than numerator, so that's where they end up. Okay, similar on this one, 7 minus 2 gives us 5 down here. So you can do that. I'm going to do that from now on. So if you want to, you can remind yourself, oh yeah, this has an exponent of 1. 2 minus 1, well, you're going to have 1p left on top. Now this 2, though, needs to come along, so you're going to end up with p over 2. Number 13 here, you can remind yourself that has an exponent of 1. Well, let's see, we have 2 minus 1 gives us 1, or in other words, we have one more y in the denominator. And basically, we would have nothing left in the numerator. If you think about it as y here and y times y here, those would cancel out and you'd be left with nothing, okay? So, in the numerator. So we're left with this, and it would just be y to the first, but you don't need to write down the 1 there. So that's the answer there. All right, go ahead and try numbers 10, 12, and 14. All right, so here, 2 minus 1 here leaves you with a 1k, and it would be in the numerator, and you just be left with a 1 in the denominator, but you don't need to write the over 1. Here, yeah, one more b in the numerator, right, and nothing left in the denominator. That happens actually in all three of these where the denominator goes away. So number 14, a little bit more complicated. You have several variables. So what I first did is I just copied over the 4 and the 2, and then 4 minus 1 is 3. There's more in the numerator, right? So that's where they end up. 4 more z's in the numerator. The y's totally cancel out. Same amount in the numerator and denominator. So, and then also 4 divided by 2 is 2. You'd have 2 over 1, but you don't need to write over the 1, or the over 1. All right, so there we go. All right, down below here, this is all about the power rule, okay? Or sometimes it's called power of a power. Let me quickly go through. These rules are all on this little reference, okay? So this sums up, we did the product rule, right? We did the quotient rule, kind of skipping around here a little bit. So here's the quotient rule. You can actually, let me go back to this really quick. You are able to actually get negative exponents. Really, it should say in the directions, make sure your answers all have positive exponents. But it is possible, like on number 7, this would also be the same. Actually, that's a bad example. Let me do like number 8. This one you could also write as x to the negative 5th. If you did 2 minus 7, if you start with the number in the numerator, well, that's going to end up in the numerator, but you're going to end up with a negative number. So you could also get x to the negative 5. That's possible. All right. Most of the time you want positive exponents, though, so you want to try to stick with those. All right, but that is possible. All right, so yeah, that's so we did the product rule, quotient rule, right here, and now we're going to do power of a power, and so, or it's sometimes just called the power rule. So what you do here, well, if you expand this out, it's like you have 3x to the 4th being multiplied, add all those. Now you're using the product rule, right? 4 plus 4 plus 4 gives you 12. But the shortcut would have been we could just have multiplied those two numbers, all right? Number 16, yeah, we expand this out. We're going to have a total of 8 x's being multiplied, and then 3 times 3 times 3 times 3 is 81. Shortcut here, you could think of this as sort of distributing or multiplying both exponents. Now notice I put a 1 as an exponent at 3. Don't forget numbers also have exponents. So you'd have 3 to the 4th, x to the 8th, which 3 to the 4th is 81. So that would be the shortcut there. I'm going to do that from now on, okay? And so those are both on here. Power of a power or power of a product. If you have more than one thing, you apply those exponents to each factor inside the parentheses here. All right. So number 17, you multiply those, you get x to the 6th. Number 19, again, you might want to write in that 1 there. This multiplies both exponents. You're going to get 3 to the 2nd times x to the 8th, and 3 to the 2nd is 9. So there you go. And then number 21 here, might want to put on those 1s. This 3 on the outside gets multiplied by all the inside exponents. You end up with 4 to the third, y to the third, x to the ninth. And then I'm going to simplify this a little bit. 4 to the third, that is 64. You can always use a calculator to help with that. Generally, you want to put your answer, if you have more than one variable in an answer, you want to put them in alphabetical order. So we should have the x before the y. All right, there's that answer. Okay, so you guys go ahead and do numbers 18 through 22. All right, so here's what I got for those. Yeah, just multiply those. Don't forget that these have the factors that don't have exponents of 1, well, they automatically do, right? So make sure you apply that exponent to all those inside exponents, even for the number, okay? All right, so I ended up with these answers here. Okay, let's move on to the back here. Now we're going to see negative exponents. So what a negative exponent tells you, one way to think about it is you can, it acts like a reciprocal, or it tells you, hey, this variable is sort of in the wrong place in a fraction. You could think of anything as a fraction, right? If you have a negative exponent in a numerator, you can actually just place that same expression in the denominator with a positive exponent. This is like x to the first. So that's why x to the negative first becomes 1 over x to the first. Okay. So another way to think about a negative exponent, if an exponent means repeated multiplication, right? If I have 3 to the fourth, that's like 3 times itself, a total of 4 times. Well, 3 to the negative fourth acts like that 3 is in 4 times in the denominator of a fraction, okay? So in a way, we're dividing by 3 4 times. So one way to think about it, a negative exponent, it's like repeated division, as opposed to a positive exponent is repeated multiplication, all right? Yeah, so here, this is kind of a leap here. I might do the number 24, show a couple more steps here. You could think of that as a to the negative first over b to the negative first. This is kind of the first time we're seeing this. But if you have a fraction, just using the power rule, you do the same thing. You apply that exponent to every exponent inside, even if you have a fraction. And again, how I think of it here is, hey, these are like in the wrong place. This a is in the numerator, it should be in the denominator with a positive exponent. This b is in the wrong place, should be in the numerator with a positive exponent. So that's how we end up with b over a here. Okay, 25. Again, this is a little bit of a leap from here to here, so let me do this in another step. You could think of this as 2 to the negative 2 over y to the negative 2. That can apply to both these. It's using the power rule. And then, again, the negative exponents, you can think of it as they're in the wrong spot. So this should be in the numerator with a positive exponent. This should be in the denominator with a positive exponent. And then, of course, 2 squared is 4. So that's how you end up with y squared over 4. All right. If you have a 0 exponent, that causes, that basically just equals 1. I'm not going to go into great detail about this. You should have learned this in the past. But yeah, anything to the 0 exponent is 1. If you need a further explanation about why that is, ask me, but I'm not going to go into it here. All right, number 27, this would just become, again, it's sort of in a numerator. It needs to be in a denominator, 1 over x squared, okay? Number 29, well, this has a couple things going on here. First of all, I would use the product property, product rule, and x to the fourth, well, the 4 is just going to come along here, this one, and then 4 plus the 3 here becomes 7. 4 plus the negative 3, well, that's 1. And hey, look at that. I don't have any negative exponents anymore, so actually I'm done. I didn't really have to deal with the negative exponent. It kind of went away because when I added those two, you just end up with 1, which you don't have to write down that 1. Ooh, 31 here. Probably the easiest way to think about this is this would be 1 over 2a times 2ab to the third, to the positive second and a denominator. And then we should go ahead and expand this out. There would be other ways to do this. You could actually use the power rule first and then have a bunch of negative exponents and deal with them that way. I just chose to go this route. And so this becomes 2 squared, which is going to be 4, and then a squared, b squared. Okay. Let's take a look at 33. Okay, so this and this, in a way, they're in the wrong spot. You could use the quotient rule here, but personally, I don't like to do that because there are just a lot of negative numbers, really easy to make a sign error here. You could, though, use the quotient rule and subtract the bigger one. This would be the bigger one, right, from the smaller one. But I'm going to go this route where I just take care of the negative exponents first. The order doesn't really matter here. So we're going to have m end of the fourth here. So the end of the negative first moved up top. I don't need to write the 1. I guess I will for right now. And then the end of the negative 4 moves to the denominator. There it is, as a positive exponent. And now I can use the quotient rule. I'm going to go bigger minus smaller so I get a positive result. And so we end up with 3 over m end of the third. Okay. All right, you guys go ahead and do 26 through 34. Or I'm sorry, 28 through 34. 26 is already done. All right, so here's what I get here. This x to the negative fourth, that goes to the denominator, right? Again, you can think of everything as a fraction if you need to. The y to the third stays in the numerator, x to the negative fourth goes down, becomes, this 4 becomes, or the negative 4 becomes a positive 4. Here, I used the product rule first, and I added the exponents of the n together, brought everything else along, and then this m to the negative fourth should end up in the denominator. Here, I used the power rule, ended up with this, and then the y to the negative sixth moves, and its exponent becomes positive. This one was a little weird. We had an a to the 0. That basically just goes away and becomes 1. All right, so 1 times b to the negative fourth, which in a way I don't have to write that 1. And then this goes up top, so I just end up with this. Nothing left in the denominator. You don't need to write it. It'd be over 1, but you don't need to write that. All right.